Okay. So this is Parker Adcock and Tanner Wakefield. We did our project on HP, and we'll be walking through the code that we wrote up for the project. Um, Tanner will be taking the profit and earnings quality section, and I'll be explaining the code later for the credit risk quality code as well as the valuation. So I'll have Tanner take it away after, of course, the first two codes of importing pandas, MATLAB library, as well as NumPy, and then just reading in the different CSV files.
Yeah, so we put them in a few different CSVs because having one mega CSV would be a headache for us, and it just keeps things nice and orderly. Here you can see we ran into an issue with that. I forgot to add in sale. So I had it in credit already, merged it into the profit using left merge. And then here you're gonna see the HPQ throughout. This is our way of checking how many values we have for HP. We didn't want to lose our values due to, even if they were outliers, so we didn't want to lose them. This is our way of checking them throughout the code. So you can see here, show HP info, just making sure we have all 9 values for HP. And then moving forward, just checking out our data here for profit, earnings quality, valuation, the different data frames. So right now, stepping into the profit, I just want to get a look at it. Here's the info, looking at the values, making sure the exchanges were in 11, 12, and 14, and using some of Dr. Thornock's code here, filling in the DLTOs, DCLO, and so this is the current portion of long-term debt, current liabilities, and I'm trying to remember IVAO. When it comes to me, it was one of the variables used in producing FLEV, and the Penman. So you're filling those with a 0. Here we're just looking at the profit.info, and then once again checking HP, making sure we're not losing any values. Here we're going to remove all values that we don't want that are outliers. However, you can see I used ORs here to make sure that we keep HP. Even if their income is beneath 0 or their equity is smaller, which it actually is, as we'll see, their equity does dip down beneath 100, goes negative for a few years due to a spinoff. And here we're removing banking institutions, and then double checking again. Then describing, making sure all the variables look nice and neat. Here we're creating the effective tax rate. Then looking at that, as you can see, we've got some outliers there, which we remove here. And then making sure we took care of those. Outliers have been removed. Then moving forward, right here, we're going to drop NAs in place and then double check HP is still there. Check the info. It looks like we've got a clean data set. We go ahead and create some of the variables here for the ROE, decomposition, asset turnover, margin, leverage, ROE. Describe the ROE. And then going here, we create some of the variables needed for the Penman valuation, OA, OL, net operating assets, net assets, pre-tax NNE, no PAT NNE. We create those variables here. This is the code that Jake created for lagging variables. So what we've done is we've copied some of that code and manipulated it for our use to create those variables. And then we went ahead and checked out HP again, make sure we didn't lose any. And then here we have average assets, and so building on the code before, using those lag variables to build out the averages. And then looking at it, looks like that looks correct. Creating the Penman ratios here. We initially did Apple, but it's too big of an outlier. So this is just the code I used before and then copied it in for the HP. Double checking we have all the HPs, we do. As you can see, it drops down to 8 here. And then this is where we're going to remove some outliers. Net operating assets, we're going to remove if it's less than 0 or average equity is less than 0. But we want to keep HP even though they violate some of these. So we see we get a pretty clean data set here. This is us checking for HP again. Looks like we have all the values. Here we're going to replace infinities with NANs, and then we're going to drop those. Looks like it cleaned up this data set pretty good, describing it. And then we're actually going to Winsorize these variables. So as you can see here, we Winsorize here, and we take anything that's beneath the 1 percentile and 99th percentile. HP actually does fall into some of these limits here. So some of their variables that you'll see will be Winsorized just due to the extreme negativity of their equity. Checking it out, it looks pretty good. Reading in the Fama French here and then merging it on here. Looks like the merge was pretty good. Here we have HP and HP for the year 2008. 2008, since the equity was negative, is not a good year to compare them at, but we looked at it anyway. Here's the 2008. We're going to use that for some of the graphs in the future. Just checking out some of the HPs here. As you can see, it's in a later one, but here you have there's a histogram of the N&O publicly traded companies. Turns out HP is a big borrower. Here we have the ROE asset turnover. You can see here they have been Winsorized on the ROE. The values are the same here. They've been Winsorized as they were negative numbers due to negative equity. But all the other variables seem to do all right. You can see leverage is kind of nutty here just because equity is negative and small. But margin and asset turnover turned out pretty nicely. Here we just have a histogram plot of all of the companies in the economy. This shows the last time HP had a good ROE, where they kind of stand in the company. So they do better than the 50th percentile. They tend to be pretty good. Here we're just plotting some more graphs. Right there, you can see asset turnover where they fall better than 50th percentile. For some reason, these didn't run. So these are just various plots that we have, plotting the profit margin, the leverage distribution. This is just some of the code I used earlier to build those out. And then this is also just multiple plots they're running right now. I don't know why they weren't running before. Here we just have the margin, RNOA, so you can see HP. HP's jumps up due to a drop in assets as graphed here, and as well as sudden drop in equity. So that they're all related there. Going into earnings quality, we do have revenue growth here as well. You can see they didn't do too hot. Earnings quality, just inspecting the data set, creating an easier data set. I got tired of writing earnings quality DF, so I just EQ DF'd it. I created accruals by subtracting income before extraordinary items and operating cash flow, as well as I took out banking, financial firms here, looked at it, looks like it's fairly clean, created some lagged variables here, and then created the regression analysis based on the industry. So you can see we have the Ys, they're not there yet. I dropped ARC. This was a data frame that I pulled in mistakenly. This I just looked at sorry, for some reason these didn't run previous to this. So let me go ahead and make sure they're all running. So here's the X, Y, Z's. I'm going to Winsorize these. You can see non-null values. They turned out pretty good. Winsorize them. Oh, there were some null variables, but we're going to go ahead and drop those later on. In the EQDF, we merge on to the Fama French here. Looks like it turned out pretty well. Here we're just setting these to integers. Bet you want to pause this real quick?
Mm-hmm.
Alrighty, sorry about that. Just had to run it one more time. Here you can see this merges correctly. Here we get all the values we need. It's all run nice and neatly. So we're going to turn these bad boys into integers, as you can see here, and then create a temporary data frame based on the industry and year, and then remove any ones that don't have enough count. So obviously we're going to remove this sucker right here. We're going to remove those. It looks like we're good here. Import stats model. Here we're going to run the regression. We've got the 4 variables as defined before and in our paper. There's a chart below that'll show what our variables are as well. This gives us the coefficients, creating a new data frame here and changing the names. We have our regression data. And then what we're going to do is we're going to merge this back onto the earnings quality. Make sure our merge is good, looks good. Here we're going to predict accruals. And then right here, what we're going to do, this SIC gets competitors based on the SIC code. HP is actually 3570, and then Dell, one of their major competitors, is 3571. So this is a good way to get competitors. Here we're going to get discretionary accruals, and then we're going to graph these. You can see HP kind of messed with their accruals in 2012. They've come back towards the industry average, but this makes sense given our data. HP struggled in this time period. Here's a graph of what our coefficients are. So for reference there. And then this is just a box plot of the accruals in the industry with the median and like that. Now jumping into the credit analysis section, Parker will take it from here.
Yeah, so we're printing out our mainframe here, and then scrolling down, we're creating net working capital, and all those different values. You can see what we use to create those. Here, simple ratios. Just taking some info from our new data frame. We merge in a file that we forgot to put in here. So we named it forgot one. Yeah, and just getting the info on all that. Go down. We just took some of Jake's code in order to create this Altman Z-score. So you can see here what we did, brought in the coefficients and created the Z-score. Got that all down here. Got this graph right here, as well as we factored in their competitors in a similar way that Tanner described earlier, using the SIC numbers and everything. Oh yeah, and here is our graph for the Altman Z-score. We could see how we got the title of it, the Y label, etc. Threw that all in to create this. As we can see through the Z-score, HP is actually trending upwards after struggling for some time, as well as the industry seems to be on somewhat of a nosedive in regards to the Altman Z-score. Going down here, again, we're reading in another file, creating a data frame for that, and then we're plotting that. Looks like the plot is not showing up. If we run that again, interesting.
I think this is just a holdover. The plot figure, we're not actually plotting anything there. The plot figure, I think I put in there on accident.
Gotcha. Froze in front of the camera. Anyways, so we're going on to gross margin, which again, we're just running pretty simple, basic financial ratios through the code, as well as we're taking the average inventory by taking a lag variable and subtracting it from the other in order to get that average that we're taking down here. And then we're adding that into our database, as you can see below here. Again, we're dropping these 2 variables, ARC and OPD.
I pulled them in incorrectly.
What's that?
I pulled them in incorrectly is what they were.
Yeah. So we're dropping those 2 variables. Now we've got, essentially the variables that we're looking for here. Calculating days in inventory, again, through a financial ratio that you can see right here, and adding in another, some other stuff that we forgot to put in. We merge that in through this formula right here, and then calculating more financial ratios like days sales and inventory, days payable, and then creating a net trade cycle from that. You can see the different steps that we took that, and then did the describe function to see what we were looking at in terms of average, minimum, etc. From there, we were able to get the competition again in that way that Tanner described earlier. We took that, put it all together for the industry average trade, and and then plotted that figure in order to get this figure, which compares the net trade cycle of HP versus the industry average. As we can see, after the split in 2016, HP, what they already had quite a big advantage on the industry, and that absolutely plummeted after the split, and that is something that they're definitely doing very well, is that net trade cycle. Anyways, we're adding this in right here, grouping by this function that we'll eventually be plotting, which gives us our I'm forgetting the word for it.
I think this one's operating cash flows to current liabilities.
Yeah, it's the interest coverage ratio. That's what it is. So we're getting that already so that we can plot that here against the industry average. This is something that, oh, actually, sorry, this is the current
Yeah, I
ratio.
think this one's plotted later.
Gotcha. So here we're plotting the current ratio. Again, something that HP is really struggling in relation to the rest of the industry. And in fact, we can see after the split in 2016, they actually go under 1.0 current ratio, which of course is something that causes concern amongst investors because they don't have enough current assets to cover their current liabilities. We're putting together everything up here to be able to produce that quick ratio, which tells a similar story as that current ratio, just that HP just does not have very many current assets in relation to their current liabilities. We never got that code for the inventory.
Oh, operating cash flow?
Yeah. I wonder if that just didn't show up.
I might have accidentally deleted it. I'll add that back in.
Okay, yeah,
but we do have the code for this one somewhere. I might have accidentally deleted it when building out one of these things.
Yeah.
So I'll add that back in.
We'll throw that back in there.
We have the graph in our paper, so you can see that, but I must have accidentally deleted it.
And then we'll launch just straight into valuation from here, creating our data frame. We're merging in, adding in receivables as well as the market value into this VDF1 data frame. And then we're dropping, again, that ARC value that was actually added in. Getting the info on that, going down, as well as just dropping NA, which is pretty self-explanatory. We're describing based off CapEx, getting net working capital, and then we're lagging that through the code that Jake showed us in prior labs. And then we'll be getting the average of those two by taking net working capital minus net working capital, the lag value for net working capital. And then we go down here, we have free cash flows. You can see the way that we calculated that here. Again, going off of what Jake had specified in class. Take the info just to see what we have here, as well as describe function. We can see max, min, as well as the average for the different functions that we have here. Below, again, we're using that same methodology as was described before to be able to receive those competitors for HP for this data. Okay, so we have the multiple. This part's a little bit finicky, but in order to be able to run this function correctly, we needed to replace the year with actual numbers. So as you'll see on these multiple graphs below, instead of actually containing the year, it's just going to have a number. But we kind of needed to go around the system in order to get that to run. But you can see here the data that we used essentially to be able to create this multiple plot. This first one is a revenue multiple. And then as we go down, we get our revenue multiple by year. These red lines, we had to go around a little bit to be able to create this. They didn't automatically go on there. So what we did is we combined a scatter plot with that box plot in order to be able to show HP's multiple in relation to the industry average. So that box plot is the industry average multiple, and then the red lines show HP's multiple throughout those years. We can see that their multiple is significantly lower than the industry average through these box plots. Here we'll be doing the EBIT multiple. Similar methodology here. One little thing of note, we had a little bit of trouble with that title, but again, we use the scatter plot in order to get the multiple for HP in relation to the industry average box plots. Again, just some more ratios that we're calculating, as well as, sorry about that. Again, sorry, but more ratios in order to create these different values to compare HP versus its competitors, which we have right here. And then here we have, this is what we're running to be able to do our DCF. We're forecasting these future years. We needed to assume a growth rate for future EBIT. In the past years, it was decreasing, but we have faith in the company. We're assuming that's going to have a growth rate of about 3%, which we put right here. Right here, we're showing the actuals for 2019, the predicted for 2020, and the predicted all the way up into the year 2023. We'll assume a tax rate of 20%. And this last line is computing EBIT after taxes. A depreciation percent of 10%. Again, calculating depreciation right here. CapEx percent of 10%, as well as net working capital percentage of -1. From that, we're able to calculate our free cash flows, which we have right here. We're assuming a WACC of 0.07, as well as the growth rate of 0.01. Here we calculate the terminal value and then the discount factors. And then by calculating those free cash flows times the discount factors, we're able to get that discounted cash flow, which we have right there. I don't know if you can see my mouse or not. But anyways, we have here the present value of the terminal value. We add that together, we get the enterprise value, which is the value of the firm, in order to show, and then the equity value actually as well below here. And then as well, we are able to divide by the amount of shares outstanding in order to get an implied share price, which is $44.1.
Which it seems like we're more bullish on HP than the rest of the market. I think they're trading at 33 as of this morning. So,
and again, that probably, and it has to do with a number of factors and a number of assumptions that we did, but with HP currently declining in EBIT, we do believe that they will kind of turn things around and get at least a small growth percentage going. So Tanner, unless you have something else you want to cover with the code, this is our presentation of the code. Just wanted to walk through each step.
That's good.
All right, thank you.